For a long time now, I've suspected, and several other more well-known schizo content creators have suspected they're lying about the population. From 10 or 15 years ago, it was always that like high 7 billions, and more recently it's been 8 billion, creeping up just a little over 8 billion now. I think last I checked it's 8.25 billion. And some sort of basic thought process was just like, oh, you're telling me that there's this many people here, but no one that I'm aware of has gone further into trying to maybe prove it in some way. And so, I guess before we get into that, I think the reason that they do that is to sort of in alignment with the space narrative, make us feel kind of small and insignificant, because if there's a lot of us that exist, then the value each one of us on our own is less valuable. If that makes any sense. Helpless, individual, atomized people, 1 in 8 billion, as opposed to my basic guess is it's about half of that, potentially even a little less than that. And the other part is, it's an actual Depop agenda. So if there's that many people, you're like, oh, well, what's the point of making another one? So what would be the method of attack to try to disprove this 8 billion number? And I'm going to reference this principle in a lot of my content going forward, and hopefully you've heard of this at this point in your life. The Pareto principle, the rule of 80-20, it's just the concept of diminishing returns, and this goes in almost everything you see, whether you're talking about the dating market or the economy, the rich people, et cetera, et cetera. The 20% of your efforts is going to yield approximately 80% of your results. Don't get too hyper-focused on that number. Just remember the concept of disproportionate results. And also that number increases as well. So in theory, 5% of the efforts would give you 65% of your results, and as little as 1% could generate 50% of your results. And so taking that principle, we want to find out where they're lying to us. And so what's the easiest way to do that? So what I've done here on this first page, you can see I've went ahead and put the populations of the largest 30 countries, because I'm not interested in disproving, the population of frickin' Australia or something even smaller than that. There's just not that many people in Australia. I think it's like 20 million or so. So these top 30 countries have, the smallest one is Sudan here, a little over 50 million. And then the top one is India, followed closely by China, coming in at just under 1.5 billion people. And so India has allegedly nearly a fifth of the entire global population, and China pretty much the same, just under a fifth for both these countries. So we're going to focus our efforts to get us the best results in finding how they could be lying to us. And so let's focus on India. Okay. Oh, and for this one, I think I pulled this off of, it might have been Wikipedia or something, and I did some basic cross-referencing. Oh, and then just going forward, we're going to be doing some rounding here. The purpose is not to say that, they say there's 8.2 billion, but there's actually 7.9 billion. The idea is that we're looking for something pretty significant. Probably at least like a 40% less, if not half or even more. So we're looking for a target of like 4 billion people in general. So we're looking for 50% approximate. So half of this, right? Alright, so the first thing you'd wanna do is, okay, India is our target. We'd wanna look at, India has its own states and provinces. Kinda similar to the United States, if you're listening to the United States or other countries. I believe it's called provinces in India, but who cares? Anyways, there are 36 of these, and you can look this up online too. And I did a check on this, and so the math checks on this, just cursory analysis, I should say. And now you will see that it's actually 1.39, but this was, I think, the data I got was from 2023, so we can just ballpark it and say, the numbers add up if you look at their provinces. So the next thing we would want to look at would be cities. And I have this sort of thesis that applies more to the West than to India, but I really think there isn't really countries barely exist. It's a very loose nomenclature. It's more about cities. Cities are almost everything in a few countries. In particular, say like Canada is only really a few cities. It's Toronto, Vancouver, Montreal. Australia, it's about 5 cities. That is almost everything. So cities is how I think they hide it. So the countries checks out, territories check out. So we're going to cities. So I got this data from a website called the World Population Review, and it's per 2025. And so what I did, you have to actually request via email the data of India's cities, populations. And this was all the way from the largest 2,900 cities. And it goes all the way down to population of 10,000. So it doesn't have the data of anything below 10,000. And so before we get into the total, I actually went through it, and so I organized it by population. I think it already came by population size anyways. You got the name of the city, country's India obviously, and then the number of people that allegedly live there. And then they also give you latitude and longitude. So one thing I just happened to notice, I was just assuming, hey, like I can just trust this data, is I found a total of 7 cities that were either duplicated or triplicated, and that amount equated to 20 million people. Again, 20 million out of 1.5 billion, that's 15, would that be like 2%? So it's, as a percentage wise, it's not too much, but that's a big chunk of people. So I had to subtract that out. And I even went through and cross-referenced latitude, longitude in the largest, the cities that were 10 million or larger. And just for reference, I found approximately 3 million map locations that were contained inside of our larger metro areas. So I'm not saying these were the exact ones, but let's just say you took this city here of Chennai, and maybe there was this one here was actually inside of it. So that could have been a double counting too. But I'm not subtracting that out, and if you do the math on that, it could be another 2 or 3%. Percentage wise, so 3 million on 110 million, that's 3%. And you could extrapolate that down. We'll just keep that in mind if we need to round, do a little rounding down later. And in some cases, there are cases of municipalities or cities that are an island inside of a circle of another metro. So, just giving you a heads up on that. So we subtracted out the actual straight up, like duplicates and triplicates. And there was one that was, I think, a million and a half people in there. So that was pretty significant. So he's tracked that. All right. So, anyways, as you can see here, these 7 are 10 million or larger. And then we'll just start scrolling down here slowly at first. And see a lot of cities that are a million plus. That's about 65 or so. And I'm going to use this bar here because as we go down more, there's your cities here that are these are in the hundreds of thousands. Still a pretty large amount there. And we're going to get into the weeds at the bottom here, so don't worry too much. Just giving you an idea of how many of these exist and all that. All right, so there's 100,000. We're at like 440 minus the original 70. So now we're going to go down to the 10,000 to 100,000. So there we go. I'm using the scroll bar now so you can see there's a lot of these guys. Okay. Look at these names. Ignore the color coding. I was using that while I was doing the latitude and longitude. I should say, I'll just explain it a little. Here's an example. This was one that was contained within another one. That's why all 3 are highlighted. I won't go into the weeds on that process. Almost there. We're in the 17,000, 15,000 range, right? You'd be like, wow, look at all this. Thousands? And these are in the tens of thousands? That's going to add up. We're going to hit it, right? Okay. So, total for all of that. So all the cities in India from a population of 10,000 to 35 million, of which there's 2,900 or so. 441 million. A lot, right? And so you'd still probably think, I was kind of hoping for more. I think I was kind of hoping for about a billion plus right there, right? But how do we kind of quantify that? All right, so now, and I guess this probably is a video you're going to probably want to actually watch, but this isn't going to be too long, maybe 20 minutes, 30 minutes or so. So what I did was I distributed out all of the cities and did some analysis of them by orders of magnitude. And that's all the stuff in white or not highlighted that's the real data, okay? So we have 110 million people live in cities between 10 million and 100 million. And there's a total of 6 cities that fit that requirement. And I put a note here just to explain that that as far as adding up the total, that's real data, but it's an incomplete order of magnitude data because it doesn't fill out. Like if there had been one city that was 99,999,999, then in theory that order of magnitude would have been filled out. So just keep that in mind, that it's real data, but it can't necessarily be used in the mathematical model as much as these next 3 lines of data. All right, so in the 1 million to 10 million order of magnitude, there's a total of 143 million, with an average of 2.2 million. And there are a total of 63 cities that fit into that order of magnitude. And note to this one, higher due to only extending to about half range. And that's in regards to this. So what I'm trying to present here is that the order of magnitudes will all contain a larger amount than the smaller order of magnitude. The only reason this one doesn't is because it only got up to 35 million. So if there had been additional cities, it would have easily, a single, one more data point if would have beat this 143, right? Because the largest city is 35 million. So that's what I'm trying to sort of mathematically model or explain here. I'm sorry if it's a little confusing, but you'll maybe get it a little bit when we get later on. So you'll see in this order of magnitude, this is the 100,000 to 1 million, you get 108 million. So now maybe you're seeing it now. So we went from 143 million to less. There's less people in this order of magnitude, despite the fact that in here we have 376 cities, but they all equal 108 million people. These ones, so way less cities, however less people. As a matter of fact, about 75% of that order of magnitude. And then we have the data for the 10,000 to 100,000. Total of 80 million people there. And a total of 2,475 cities. And that number is about 73% of the preceding order of magnitude, going in reverse order. All right, so we actually have a little bit of a sequence we can use. We have 75. It's like, finished, what is the next number? 75, 73, x. Well, it's decreasing by 2%, right? Now, this is not hard science. It's just that's what you have to go with. You have to go with the data you have. And we don't know what would be in these lower orders of magnitude. Keep in mind, we started off at 10 million plus, and now we're in the 1,000 to 10,000. Okay? So, logic would have you say, we're gonna keep going down. We're gonna keep decreasing by a slightly increasing amount of 2%, right? So 73%, 71%, 69%, 67%, and 65%. So if you do that, you get these numbers here: 56 million, 39 million, 26 million, and 17 million. But then I also wanted to give it a more, so this would be more of my thesis, right? What would be something a little bit more, give it against my case, if you will. And so that in that case, it's a total of 138 million additional people in cities or municipalities less than 10,000. And the reality is, a 1 to 9, because do you think of it as a city or just a cluster of humans, right? We're trying to capture the whole population. So there probably isn't a city in the 1 to 9, right? And would there even be one in this one? They would just all be homeless people that are just in the wasteland that are attributed to one of these smaller ones. But again, so then I went into these other two mathematical principles. So there's this concept of Zipf's law, and just real quick, it's just the idea that when it comes to order of or distribution of occurrences, there's going to be a larger amount in the first order of magnitude, and then it's going to decrease significantly as you go up, probably close to about 10x, give or take, right? And then you have something called Benford's law, which is used in accounting forensics. What Benford's law is, if you have a possibility of a sequence of numbers from 1 to 9, there's more likelihood that it's going to be the number 1 than number 2, and then number 2 than number 3, all the way through number 9. I think it's about an 18% chance you're going to get a number 1, and then decreases. But if you actually average that out, you get this 3.44 coefficient. Feel free to YouTube it. You can probably find a 2-minute video explaining it. The point is, you might assume if you average them out that you're going to get closer to a 5, but because of the way numbers actually occur from a starting point, it's actually 3.44. And so what I did was I noticed that the amount of cities, and I can't use this first one because of what we explained earlier, was decreasing, so from 60, or increasing, I should say. So from 63 to 376, that's approximately 6 times as many cities. And then from 376 to 2,475, that's approximately 6.6 times as many cities than the previous order of magnitude. So 6.6, again, this is the data we have, so let's assume the amount of cities is increasing, and it's increasing at an increasing rate. So we're going to increase it at 0.6, so 7.2, 7.8, 8.4, and 9. And so this is the amount of cities, or clusters of people, I should say, especially when you get into this lower ones, that you would get. And so then we would take that number, and we would assume that the average number per Benford's law is 3.44. Oh, and by the way, look at this. The last one actually came pretty close, and these other two, a little underperforming, but not fraudulently or suspiciously so. But that's pretty good. So we're actually being a little bit generous, I think, but we're going to give them that. We want to be generous for this analysis. And so Benford's law, 3.4 coefficient, or this number. So for the first order, 3,400, second, 340, third, 34, and a group of 30 homeless guys at the bottom there. And then multiply that by these numbers, by these numbers here. And this is the amount we get in each of these lower orders of magnitude, the last 4. And on this side, it equals out to 184 million. So my sort of bearish scenario on the rural areas, so all the population below 10,000, my bearish estimate, 138 million. The bullish estimate, 185 million. Okay, so giving us a total population of 580 million, or 625 million. And so I just went ahead and averaged it out at 600 million. So, cabal number, 1.45 billion. And if you divide that by this average here, misrepresentation of 2.5. Another thing, and I might go into this in another video, and I don't have proof of it yet. I have a sneaking suspicion and a brain that likes to think of ways to disprove things. But so the largest city is Delhi, 35 million people. There's actually another city, Tokyo is actually slightly larger in Japan, but there's something about, and I know it probably is the actual largest city, but is there really 35 million people in an area that is about 1,500 square kilometers? And for reference, Canada is a country of about 35 million people, just over, I think. And Canada is a country of 10 million people. So is this city? It's big. I'm sure it's a lot of people. It's probably absolute hell on earth. But does it really have the population of Canada in 1,500 square kilometers? I don't know. For another video. And so I also did the same analysis with China, and we're not gonna do territories added up just like before. But then The only thing to note with this one, it's a little, my model is a little, what's the word I'm looking for? Not as trustworthy because I didn't have the data for the 10K to 100K, so I really had to be kind of liberal with my modeling here. But I just assumed, again, the same thing, that it decreased significantly from the 1 million to 10 million to 34 million from 32 million, or 320 million from the complete data set. Again, the 10 million plus data set, we can't really use that in the mathematical model. We can use it in the population totaling. So that amount was 9.42. So being very generous but liberal at the same time, I'm assuming, hey, what if we just said that all of the orders of magnitude under it had the exact same amount as the 100K, even though it's highly improbable, and then I used a increasing amount of cities, but whatchamacallit, I did the other analysis be way smaller, but I'm not even like, so that one came out to 468 million, and the other option, being extremely generous, 634 million, with an average of 550 or 551 million for China. So let's go back to what we were told. China, we were told around 5 billion. Probable population, 600 million. And the amount of missing people, around 860 million or so. And so, based on this model, the data that I have, and probability, 41% of what they say. China, 550 million probable max population, missing 866 million people, and the percentage of that is 39%. And then I went ahead and just said, assume you've got 8.8 billion people based on the India percentage. So if they are lying on at that percentage level, and you extrapolated that on the world, you'd get 3.3 billion. I'm not married to, again, being less than 4 billion, because I actually think they're lying more on these top guys. As you get lower and lower, it's probably more and more accurate, and probably the bottom 100 countries that I don't even care about. They're probably almost like they're basically 100% accurate. I think it's all being kind of hidden in the about half of the overpopulation is right in these top two countries. I don't think the United States actually is. It's actually pretty accurate, I think. I don't think there's actually very many people that are being reverse, I guess, hidden in the United States. I guess the one thing you could say is that what if about 100 million of people in the United States are actually people that are from India or China, right? So maybe that's how they overestimate the United States. They're actually 350 million Americans. There's like 200 million Americans, and then 100 million immigrants, and all that. But I wouldn't be surprised if you found similar ratios of mathematical modeling that would say the people aren't here that they say. And the excuse is always, the plausible deniability is, it's mostly a rural population, and they can just kind of say that, and I can't necessarily 100% disprove that, but logic would tell you that as you look at Google Maps and you see these large metropolitan areas, you scroll around and you think, well, if that represents 1/3 of the people, where the other 2/3, no, I don't think so. But anyways, hope you enjoyed the video. Hope I didn't get too much into the weeds. Um, Leave a comment on if you disagreed on anything, or if there's something else, another methodology. I'm gonna probably be doing a couple more on this. I might do another video on another specific country and other demographic stuff in general. But I just wanted to give a nice, like, legit stab at it. And honestly, it's one of those situations where someone pointed a gun at your head, or maybe if there's money on the table, and you say, "What's your best guess?" And I'd probably go that India has a population of around 600 million, or way less than half of what they're telling us. So, thanks for listening, guys.